Good afternoon. So I'm trying this new thing where I put a video with my face on it, so maybe that can make things a little more interesting and interactive. So today's notes have to do with air pressure and how they relate to fronts as the air masses start to move and collide with each other and they begin to interact. So make sure that as you're watching the video, you also listen. And there are going to be several parts of this video where, again, I'm not going to show you the answers on the screen, but you need to make sure that you listen so you can hear what you need to fill in on your table. So if you have ever seen a news report with the weather forecast, or maybe you have a weather app or you've read one online and you've seen that high pressure systems and low pressure systems are mentioned a lot, it's because these areas are characterized by where the air goes as it circulates through the atmosphere. So low pressure systems are characterized by air that's rising because it's less dense and it's being heated, and so it gains moisture as it goes up into the troposphere, because as it goes up, we remember that the air temperature ends up going down, so we have condensation forming. High pressure systems are characterized because the air sinks as it becomes more dense and it is cooler, and so as it goes down towards the ground, it gets drier as a result. We all know that temperature is measured by a thermometer. You've had experience doing that in class, and I'm sure that you've had experience with that when you've been sick. You may have heard this before, but just to remind you, air pressure is measured with a barometer, and a sign of an approaching front is often a drop in air pressure. So scientists keep an eye on that to let them know when a front is coming, and that way it can signify certain types of weather that will come with the front. We've talked before about how hot air is usually less dense than cold air because of the way the molecules are spread out based on their temperature. So density differences between two large air masses will keep them separated from each other. So the cool air mass is dense, and it typically is not going to be able to mix with the warm air masses, and so we end up having a front. And remember, a front is the boundary that is formed between the air masses. And I like this picture here at the bottom because you can easily see where a boundary is with this cloud line that seems like it's approaching. Where we have the boundaries between the air masses, we can typically expect to see some type of stormy weather as we transition from one air mass to another. So a lot of times we'll see different types of clouds, we'll see types of precipitation, and often storms. Speed of the moving front will also affect how intense the weather conditions are. So the faster the front moves, the more severe we could expect the weather to be. So here on this weather map, you can see examples of different types of fronts that are written out on the map. You can see the capital L and the capital H. Those both stand for low pressure and high pressure systems. And then you see these different colored lines that have different shapes on them, and those represent the different types of fronts. So as you take notes on all the fronts, you'll see what all of these symbols mean, and it can help you interpret what type of weather is taking place at those areas. So we've got 4 different types of fronts to discuss. One is cold, then we have warm, occluded, and stationary. The first type of front we'll talk about is a cold front. So what happens is we end up having these 2 air masses. One is cold and one is warm. And as they come together, they don't mix together, but what happens is the cold starts to slide underneath the warm. It pushes the warm air up. So when you see a weather map, you'll see a blue line with these little blue triangles on it, and that indicates the boundary between those 2 air masses and that we have a cold front approaching. And the triangles actually point in the direction in which the front is moving, so it'll kind of point towards where it's headed next. A high air pressure is associated with a cold front, so that means after the cold front has passed through, you can usually expect to have sunny and fair weather. So now we have warm fronts, and again, this is dealing with a cold and a warm front together as they come into contact. When a warm front is advancing onto a cold front, it's not going to push up under it because the warm air would rise, and so what it ends up doing is ends up sliding over the top of the colder front. So when you see a weather map and you see red lines with half circles on them, that shows where the warm front is. and the circles point in the direction that it's moving, kind of like the triangles do with the cold front. A low pressure is usually associated with warm fronts, and so this means it typically will bring about cloudy skies. It'll have overcast weather, some drizzle, possibly even rainy and stormy weather. So cold fronts and warm fronts do have some similarities and some differences. One thing that you can expect from both of them is some type of precipitation or cloud formation. One thing that's different is that cold fronts do move faster than warm fronts, and so you'll see the storms pass more quickly and clear up. Weather activity in a cold front is often violent. It happens directly at the front instead of lingering the way a warm front does. So you might see more severe thunderstorms. Cold fronts also have sudden gusty winds high in the air, so it creates turbulence for jets and other planes that are trying to go higher into the troposphere. The weather activity in a warm front generally happens before the front passes completely through an area, and you'll expect to see a lot of steady rain or drizzle for a long period of time. Sounds familiar. In a warm front, the cloud formation is very low, so it often would affect people's visibility. It might make it hard to drive because of the fog that you would expect to see. So an occluded front happens when we have three fronts that interact. Typically, it'll be two cold fronts that kind of converge onto a warm front, and as they come together, it pushes the warm front up above the both of them. So when you see it on a weather map, you'll see the combination of the red and blue colors to make purple, and instead of coming up with new shape to represent the occluded front, they'll take triangles and half circles and alternate them on the line. And these circles and triangles will also show the direction that the front is going. They'll face that same direction. Finally, if we have an object that is stationary, that means it's not moving. So a stationary front means that it is either not moving, it's kind of camped out over an area, or it's moving so slowly that it appears to have no motion at all. When you see it on a weather map, you'll see alternating red semicircles that point away from the warm air and blue triangles that point away from the cold air. So stationary fronts can cause many days of really dreary weather, so you're not going to see the sun for a long time if you have one of these fronts stationed over where you live. So this is the part of the video where you need to be sure you're listening as well as paying attention while watching it, so that you'll see how you need to fill in this last chart that reviews the information that we just learned, and we can put it in a way that we can compare all the information right next to each other. So we got the cold front, and remember what happens is we have the cold air and the warm air coming together, and the cold air as it advances starts to push up underneath the warm air and makes the warm air go up because the cold air is more dense, and more dense things sink. So when we see this on a weather map, you'll see a blue line with blue triangles pointing in the direction that the front is going. The warm front is when I have a warm air mass that's going up against a cold air mass, and it ends up sliding up over top of it because the warm air tends to rise. And so you'll see on a weather map that it's a red line with red semicircles pointing in the direction that the front is moving. Then we have an occluded front with three different air masses. We have two cold air masses coming together and pushing up a warm air mass between the two because it would rise above the two of them. And when you see this on a weather map, you'll see a purple line that has alternating purple triangles and semicircles, also pointing in the direction that the occluded front is going. Finally, the stationary front means that it's either moving so slowly that a region is having to deal with this front for a long time, or it's not going anywhere at all. And when we have our symbol on the weather map, you'll see alternating blue triangles and red circles on the same line to indicate that it is just sitting there over a certain area. So just like I remind you every other video, if you have any questions or if there's anything that's confusing to you, please make a note of it on your paper, and that way in class we can discuss those things that you're confused about and hopefully clear everything up. You have a great evening, and I'll see you in class.